And he said, this could mean that the atomic clocks are reset during some global disaster. Oh, yes, indeed. And what was that global disaster? FLOOD, right? I mean, do you have any evolutionists that will accept, dyed-in-the-wool, I'm not talking about creationists, the dyed-in-the-wool non-creationists that will accept a universal flood? I haven't found one. I have not found one. Okay, so this is the question. And of course, Uniman's just pointing out the difficulty all over again. Okay, now we're going to get into some of the aspects of the nitty-gritty of this problem. Do you want to go on at this point or take a little break and come back to this, or how do you feel? Are you too bored already? Do you need a break? Go on? Okay. All right. Okay. Here's what we're talking about. And this was taken from a paper that I didn't get to give, but it's been written anyway. And we're talking about a minimal quantitative model which treats the question of accelerated decay rate. What kind of model could we use that will actually give us enough energy to really cause these nuclear isotopes to have a decay rate change? Okay? And we're looking at conditions that would not be in the solidified stable Earth, because there just isn't that much energy there that can impart those millions of electron volts of energy into those nuclei. You need an environment that would be much, much more energetic. And so you remember, if those of you who were here when I gave the previous talk on the origin of chemical elements from water, I used as the basis of the origin of chemical elements that the water that God created was transformed into a plasma. And that meant that the water molecules were broken apart. All the atoms of hydrogen and oxygen, which make up the water molecules, were all stripped down to their nuclei, and that was a very high energy plasma environment. And in that plasma environment, the processes went on to create all the elements. And I talked about that. Well, it's the same plasma environment that we talked about then that we're talking about now. That plasma environment not only created all the stable elements, but it created the radioactive elements as well. Okay? So the geological or geothermal conditions within the first 3 days or the third day of creation would seem to be favorable to accelerate this rate, if you want to admit a plasma. Okay? Baumgartner doesn't necessarily agree with that, but I'm not worried about that. Okay, so if we take the Genesis account, as I said, literally, it's not unreasonable to conclude that the chemical elements, and I talked all about that in the last talk, and they might have the CDs available, you can get it, and they were produced all in that time frame, okay? Remember, God's Spirit moved over the waters, and that Hebrew word can mean what? Agitating or imparting energy, right? The idea that that water is being broken up, being changed into what? A plasma of nuclei, all right? Okay, and so all of that would have happened within those first 3 days of creation. Now here are the foundations of the model. All isotopes, including radioisotopes, had already been created in their fixed ratios. That was a process that had been determined by the nature of what they were to begin with. So that didn't change with time, at least initially, right? Okay, so those conditions would have been essentially the same if the Earth had not, the environment of the Earth had not changed. In other words, they're the conditions that we see in the Earth's crust today, supposedly, although I don't believe that they were always originally in the same ratio by any stretch of the imagination. The relative concentration pertinent to the study, having regarded as having uniform distributions in the crust, currently accepted. Well, why do I have to do that? Because I know that based upon our modern knowledge of where those radioisotopes are, they're not way down there near the mantle, they're further up into the crustal portion. They've all been displayed up in there. So you've got to have some quantitative numbers to deal with, and that's where we get those quantitative numbers from where those isotopes really are. Okay? That's the reason for that. We have no way of guessing what they would have been originally anyway. So now, since the geothermal energies of creation would have been the same for all the elements, right? Okay, in the plasma environment, then all of the pertinent elemental nuclei will be treated within the dynamics of what the plasma does, right? The plasma framework. And we will have two types of dynamics that are involved here. One is magnetohydrodynamics, which is a very strong environment in the plasma. The other is electrostatics of the plasma. So those are the two main factors that are involved. Now, the actual dynamics, the rheology of the mantle, which is of course not a solid entity as we understand it to be, but it is more liquid, right? It's crucial to geothermal stability of the Earth as it's structured now. But it wouldn't have been a factor in the plasma because the plasma was all the same. So the plasma was actually, we had no divisions into crust, mantle, and all of that. We had what? One plasma initially, right? Eventually it's going to become what? Crust, mantle, core, right? But not in the beginning, okay? So this model is focusing on that portion of the primordial plasma which conforms ultimately to the formation of the crust. I don't know how the mantle got separated from the crust, and I don't